So this is DenseNet. So DenseNet is a dense convolutional network was designed to solve two important problems. That is vanishing gradients, similar to ResNet, and loss of useful features from earlier layers. So DenseNet takes the idea of ResNet even further. Instead of reusing one previous outputs, it reuses all previous outputs rather than reusing one previous output. So in ResNet, a residual block does f of x plus x and the output, where x is input identity and fx is transform features. So the input is added back to the output from the input x to the layers, the f of x, and there is preserved x, and you combine them adding together, and then there's an output. But in the DenseNet, we concatenate all the values. The learned instead of adding, it keeps everything. So the original features will never disappear. So what is a dense block? A dense net is built from multiple dense blocks. Inside dense block are many dense layers. Dense block, layer 1, layer 2, layer 3, layer 4. That is a dense block. Consists of dense or many dense layers. So the special thing is each layer receives the outputs of all previous layers. So example, layer 1 input is x and layer 2 input is x, the layer 1, and layer 3 input consists of x, layer 1 and layer 2, and therefore consists of x, layer 1, layer 2 and layer 3. So every layer has access to all previously learned features. So the dense layer structure, a dense layer actually contains two parts. So from the input and 1 by 1 convolutional or the bottleneck, and 3 by 3 convolution and the feature extraction, and then the new features. So the two dense layer parts is bottleneck layer and feature extraction layer. So bottleneck layer is the bottleneck uses 1 by 1 convolution. So the purpose is to reduce channels, make computation cheaper, prepare data for the expensive 3 by 3 convolution. Example, we have input 4 channels. So the bottleneck would be for channels. No reduction here because it's already small. But later, as input 64 channels, then the bottleneck for 64 would be from 28 to 32 or 64 depending on the design. So the key idea is bottleneck changes channel count before the expensive convolution. Next is feature extraction layer. So the after bottleneck, we're going to do 3 by 3 convolution. This learns new patterns, examples, edges, corners, textures, shapes, object parts. The number of new feature maps produced is controlled by growth rate. An example, growth rate is equivalent to 2, so the layer produces 2 new channels only. So what exactly growth rate? This is one of the most important DenseNet concepts. So growth rate is equivalent to the number of new feature maps added by each dense layer. So let's say we have the growth rate of 2. So layer produces 2 new channels. Let's say we start the 4 channels. After layer 1, it will equivalent to 6 channels. Why? Because we have the growth rate of 2. So 4 plus 2 equals to 6 channels. And after layer 2, we have 6 channels. So we have the growth rate of 2. Then we add it together. 6 plus 2 is 8 channels. And after layer 3, we have the 8 plus 2 is 10 channels. And after layer 4, there are from the 10 channels, we add the growth rate of 2 equals to 12. So channels keep growing. That's why it's called growth rate. So why concatenate instead of add? So the ResNet is equivalent, the output of the rest is equivalent to the input plus new features, right? So the old information and new information get mixed together. Old information and new information get mixed together. Then in the DenseNet, the output is everything is preserved. the input, the new features from the all previous layers, everything is preserved. There is no mixing together. So if I had input 4 channels, the new features is 2 channels, and the output is 6 channels. Because 4 is old channels and 2 is new channels. Nothing is overridden. By the way, the channels we're talking about here is the feature maps, or the learn feature. So why preserve all earlier features? This is the biggest idea of DenseNet. Suppose layer 1 learns edges, and layer 5 learns corners, and layer 10 learns eyes, and layer 20 learns faces. And DenseNet, layer 20 still has direct access to the edges, corners, textures, eyes, and everything from earlier layers. So this allows later layers to combine low level and high level information more effectively. So the DenseNet forward flow. So the high level architecture from the input image, we did the initial convolutional. After that we have the dense block 1, and we did the transition layer. Next is dense block 2 again, and there is a transition layer, and then another dense block 3, transition layer, and another dense block 4, and then finally we have the classifier to classify the image. So this is exactly what we did here. So what is transition layer, by the way? So channels keep increasing. Example 64, 96, 128, 116, 192. Eventually the network becomes too large. So DenseNet solved this using transition layer. So its job 1 is compress channels. It uses 1 by 1 convolution. So example 16 channels will reduce to 8 channels using compression factor. Next, its job number 2 is downsample feature maps. Uses average pooling. Example, from 56 by 56, we reduce it to 28 by 28. This reduces memory and computation. So why DenseNet helps gradients? Let's say in a normal convolutional neural network, it flows layer 1, layer 2, layer 3, and so on and so forth until the layer 100, for example. So gradient must pass through every layer. It may vanish, okay, as it go to every layer because of the calculus behind it, the chain, okay, the chain calculation, the calculus, it may vanish. So DenseNet creates many direct paths. So from layer 1 to layer 100, layer 2 direct access to layer 100, layer 3 has direct access to 100 layer. So gradients can flow more easily backward. This similar to ResNet benefit, but even more extreme because every layer is connected to every later layer. So DenseNet versus ResNet, final intuition. So ResNet uses addition while the DenseNet uses concatenation. ResNet reuses one earlier output, but the DenseNet reuses our earlier outputs. ResNet use the residual blocks. The DenseNet use dense blocks that consist a lot of layers, of multiple layers. And ResNet output size may stay similar, but the DenseNet channels grow continuously. And ResNet fewer connection, but the DenseNet many dense connection. And ResNet helps gradient flow, and DenseNet helps gradient flow plus feature arrays. But as you can see, the DenseNet is only the enhanced version of ResNet. So DenseNet keeps every feature maps produced by earlier layers and concatenates them with new learned features, allowing later layers to directly access all previous learned information while improving gradient flow and feature arrays. So this is why DenseNet is often described as each layer receives the feature maps of all preceding layers.